So hello everyone, we are here for video presentation representing Dr. D.Y. Patil School of Engineering Polytechnic, Department of Mechanical Engineering. So starting with the introduction, myself Sahil Pawar with my team members Shoaib Maniar, Darshan Gawas and Atharva Daitulu with our project guide Professor Chetan Patil. So topic for today's presentation, design and fabrication for vertical axis wind turbine, Savonius type. So let's see the basic presentation outline and content for this presentation. So we divided this presentation in three aspects: what, why and how. What is a Savonius turbine? What is its basic principle? Why we chose this as our project and what are the changes we made to increase the efficiency of turbine and make our project successful. What is a Savonius turbine? Savonius turbine is a type of a vertical axis wind turbine which rotates about its vertical axis, used for converting the force of the wind into torque on a rotating shaft. Basically, turbine consists of air follicles, also called as blades. The blades are in cup shapes. The main objective of this turbine is the more the drag is produced on the blade by the wind velocity, more the rotation is obtained on the shaft, and generating setup is used for converting this rotation into electricity. The main motive of this project is to increase the efficiency of the turbine at its maximum efficiency possible. Why we selected as this our project? As the world population is increasing day by day and there is more demand for energy, the emission of CO2 is increasing day by day, leading to the global warming. Also, the carbon footprint of an individual is reached at its extent level. To tackle this problem, the main solution is the renewable energy. Renewable energy plays an important role in such type of situation, where the major need of for humanity is power, and in this case, wind energy has been identified as a promising renewable energy option for fulfillment of energy. Aim and objectives. This project is about designing and manufacturing a drag-type Savonius vertical axis wind turbine to efficiently convert the wind power into the useful energy, that's the electrical energy which is mostly consumed. The main objective is to utilization of wind energy from the vehicle running on the highways, to increase the watt at its maximum efficiency possible, to make appropriate changes to the turbine to fulfill the basic and small need of energy consumption. To obtain this objective, we mainly focused on the three elements of the turbine: blade, supporting plate, also called as guiding vane, and air pockets. So let's see the basic difference between our proposed model and traditional Savonius turbine. As we can see, the cup-shaped blade from the traditional Savonius turbine are replaced by the spiral directing blades in our proposed model. The supporting plates from the traditional turbine are flat, which are replaced by the conical shaped guiding vanes. The main element highlighting our project are the air pockets. So let's address the every element of our project. So beginning with, so we run an ANSYS Fluent program to get and conclude the perfect number of blades to get the maximum efficiency of the turbine. As we can see, the pressure counters for 3 blade setup, 4 blade setup and 2 blade setup. As we can see in the 4 blade setup, the main blade with the blade opposite to it are creating equal and opposite reaction to each other, cancelling each other's effect, reducing its efficiency. As well as in the 2 blade setup, the blades are acting as a wall for the wind velocity. Well, in the case of 3 blade setup, most of the energy is concentrated at a single blade. Same as in the case of the velocity counters of the blade setups, the 4 blade setup and 2 blade setup are acting as in wall, whereas the maximum energy in the 3 blade setup is concentrated on single blade. So we get concluded with this pressure and velocity counter, the 3 blade setup is the most efficient for the turbine.
Air pockets. As we know the basic principle of the 7S wind turbine, more the drag is produced, more the rotation will be obtained and more the energy is produced. So we come up with the idea of air pockets. Air pockets are basically cone-like hollow structures which can be fitted on the blades. It basically gives an extra volume and space to air to provide an extra push to the blade. As in this traditional Savonius turbine, the fluid after hitting the blade leaves the blade set of composition, whereas in our model, the layer of velocity air which hits the blade gets captured in the air pockets and maximum energy is extracted from the wind layer. It's like less space and more capturing. More surface area is provided with the help of air pockets at less space. Number of air pockets can be added on the single blade according to the structure and stress concentration on the blades.
Supporters or guiding vanes. The main function of the guiding vane is to cover the more area of wind and guide that wind towards the blade. As we can see in the image, the main function is only to capture the more the area it can possible and also provide and support to the blades of the turbine.
This is the proposed sketch and the actual model. The shaft with the bearings are supported on the frame by means of supporters present at both the ends, whereas the blades and the guiding vanes are supported on the shaft. Due to wind flow, the blades start rotating according to the direction of wind. At the same time, the guide vanes present help in diverting the wind towards the blades of the turbine, helping in the flow of wind and thus improving rotation of the wind turbine. As these blades rotate, they also rotate the shaft. This rotation obtained on the shaft is further transferred to the motor by means of belt pulley setup. Advantages: this turbine can accept wind in any direction. Low production cost as compared to horizontal axis wind turbine. These are transportable from one location to another. Quieter in operation, so they don't disturb people in residential areas. It is easy to install as compared to horizontal axis wind turbine. They can also work at low wind speed. Easy inspection and maintenance. These can be placed in more confined space as compared to horizontal axis wind turbine. Disadvantages: difficulty in maintenance, poor self-starting capabilities. There is a over drag on blade when they rotate. Vibration can be an issue. Low efficiency as compared to horizontal axis wind turbine. Applications: main motive of the project was charging of electrical vehicles, powering of street lamps, gate and tollways. This turbine can also be used for household purpose, so these can be installed in villas, buildings and houses. We would like to thank AICTE, ISTE, MSBT and Government Polytechnic Mumbai for arranging the presentation and for their valuable time. Thank you.